All right, P4, graphs of equations. I'm going to start by graphing these two equations right here. Your textbook and your homework will have some problems where you're going to have to set up a table, and what they wanted you to do is they'll give you values that might help you graph, like x, y, you might have -2, -1, 0, 1, 2. Then you need to find the outputs, and for this graph, put -2 in, you're going to get 9, and -1, you're going to get 7, 0, you're going to get 5. Plug in 1. 1 times -2 is -2, plus 5 is 3. Put in 2, you're going to get an output of 1. That's all you're doing whenever you're getting a table. And then you're going to be asked to graph it afterward, of course. Let's do x, y here. -2, -1, 0, 1, 2. So we're going to get 1, 4. Put in 0, you're going to get 5. Put in 1, you're going to get 4. And then put in 2, you get 1. And what does that look like? -2. Somewhere up there. I think that's 9. Yeah, I counted 9. And then down 1 there. Right there. Hey. And oh, that is 4. Never mind. Ha. 2, 3, 4, 5, 6. That should have been a little higher. We actually had 9. We'll make another line there to make it work. There we go. Yeah. And there. And right there. I missed that completely. Whoops. But you get the picture here. And then for the other one, x squared. So hopefully you remember that that should be a parabola right there. It's going to be facing down because our a value is negative. So 0, 5, 1, 3, 4, 5. And there is our graph there. Right. So here we are going to find the x and y intercepts here. I'll write that as directions. Find x and y intercepts. Find x and y intercepts. That was a terrible y. Let's fix that. Not much better. We'll roll with it though. Intercepts. So the trick with finding the x and y intercepts, if you're trying to find the y intercepts, put 0 in for x. And if you're trying to find the x-intercepts, put 0 in for y. So for x-intercepts, put 0 in for y. And let's isolate. So isolate x from there. Square both sides. Square both sides. 0 equals x plus 4. Subtract 4. Subtract 4. You get an x-intercept of -4, which also can be written as -4, 0. Let's put in 0 in for x and find the y-intercept. And simplify, we're going to get 2. And 2, 0. So your y, not 2, 0. It will be 0, 2. So y-intercept 0, 2. And an x-intercept -4, 0. Next, we got y equals 2x cubed minus 4x squared. Let's do the x-intercepts first. And as you can tell, this is a polynomial. When we have a polynomial, we're going to need a factor. Okay? And of course, every time we factor, the first thing we should look for is finding the GCF. I know for those of you who've had me before, you've heard me say it, and hopefully your other math teachers, whether it was Algebra 2 or Pre-Calculus, said the same thing. But we need to find a GCF. So that's going to be 2x squared. And then when we factor out 2x squared, set your factors equal to 0. And so we're going to get two x-intercepts. If we divide by 2 and then find the square root, that's going to get us just a big 0. X equals 0, and then add 2, you're going to get x equals 2. So your two x-intercepts are 0, 0, and 2, 0. If we put 0 in for x, if I put 0 in for x, that's just going to give me another 0. Right? 0 squared, 0. 0 cubed, 0. 0 times anything, 0. So you're going to get 0 minus 0, which is big 0. So your y-intercept will be 0, 0. Now we are going to talk about testing for symmetry. There are three main types of testing for symmetry. I gave you a beautiful chart on your guided notes. I recommend you use that or make a chart of your own to kind of help you organize this. So first we got symmetry with respect to the x-axis. We know a function is symmetric with the x-axis when x comma y is on the graph, as well as 0, or excuse me, not 0, x comma negative y. Okay, so if you're given a function and you plug in just x for x and then negative y where you see a y, and it's the same function, it will be symmetric over the x-axis. For the y-axis, x comma y is on the graph as well as negative x comma y. And finally, over the origin, meaning over the point 0, 0, if it's symmetric over the origin, that means x comma y is a point on the graph as well as negative x comma negative y. Okay. Once again, just like the other ones, if you put negative x in and put negative y in, you get the same function. It is symmetric over the origin. There are times when it is both, okay? But there's sometimes when it's not symmetric over either, okay? But we can test for them, and we're going to do a couple practice rounds of this. Alright, we have two examples here of functions, and we are going to test symmetry of both these functions. I'm going to go in order of x, y, then origin. Okay. So x, y, O for origin. Alright. Go. So whenever x comma y is on the graph, x comma negative y is as well. So I plug in just x and then negative y. Negative y squared is y squared. And is it the same thing? Yes, it is. So yes, it is in fact symmetric over the x-axis. Now let's try the y-axis. Throw in negative x. No. Clearly it's going to be a big no. That's a different function than what the original was, so no. Aren't. Let's do origin. Negative y, negative x. What happens? No. Not symmetric over the origin. Now to the other equation. Let's do x once again first. So that means we're putting in negative y. And negative y squared, we need to simplify. That's going to be xy squared plus 10 equals 0. So it's the same thing. Yes, it works. Once again, we get another x-intercept. Nice. Let's try symmetric over the y-axis. So we're going to put in negative x and Yes, that is going to be different. So no. And then let's do negative x comma negative y for the origin. And negative y squared is going to be y squared. Is that the same? No. Still a different equation. So nope. Now, let's talk about what this means real quick, because I did not mention that. So if I were to graph any of these functions, that means, as we recall, this is your x-axis, this is your y-axis, and this is your origin. So if it's reflecting over the x-axis, that means whatever's happening up here will be the same on the other side down here. If it's over the y, so what's happening over here is going to reflect right over and on this side as well. If I were to graph the first function, it would look like that. And look, what's happening on top of the x-axis is the same as what's happening below here. Let's talk a little bit about circles. So we got the standard form equation right here. Standard form. Alright. What does it represent? H comma k is the center. Radius is your r. And x comma y are all the points on your circle. Points on circle. Okay? We're going to do a couple quick examples of this. Here we got two examples. First one, I'm telling you the center is at 2 comma negative 1, and we have a radius of 4. So we use the equation x minus h, which is 2 in this case, so x minus 2 squared, plus y plus 1 squared equals, now be careful, you're not going to put 4 exactly, remember it's 4 squared, which is 16. Because remember, the equations are squared, so you make it 4 squared, which will therefore be 16. Now, one part of the second problem is easy. We have the center, which means we have x minus 3 squared plus y plus 2 squared. Because remember, we're putting in h comma k. The center represents h comma k, so h value goes right there. K value goes right there. Now, I don't have the radius per se. I just said a solution point is negative 1 comma 1. Meaning, one point on your circle is negative 1 comma 1. Now, how are we going to find the radius? Remember what the radius means. Radius is the distance from the center to any point on your circle. So I need to know what the distance is between the center and that solution point. So what do we got to do? You got to use your distance formula. And if you forgot your distance formula, here you go. Some people switch the 1s and the 2s. That's fine, you do you. So that's going to get us negative 1 minus 3 squared. And 1 minus negative 2 squared. Which is going to get us 16 plus 9, which is equals 25. And that's going to get us 5. So therefore, it's easy enough. R is 5, so that means the equation is going to be equal to 25. I appreciate you watching, and we'll see you in class.